Welcome to Unit 2, Algebraic Reasoning Part 2. This is Mr. Valentine.
And I'm Miss Holland. And the target learning goal for this part of the lesson is I can represent and solve multi-step problems involving the four operations with whole numbers using equations with the letter standing for the unknown quantity.
Wow, that's a mouthful.
Sure is. Let's jump right into it. So it looks like for this lesson, we're going to be doing word problems.
Hot dog.
Okay, let's look at this one. Deja made $45 a week babysitting for 3 weeks. She spent $50 on gifts for her family. How much money does Deja have left? Now for this, students are to be able to read this equation, make sure they understand it, and be able to write an equation based on the information they just read.
That sounds really good, Miss Holland. So can I go ahead and give this a shot?
Sure can.
So just reading this word problem, I have some very important information. First and foremost, I need to pull out. First and foremost, I know that Deja is making $45 a week, and she works for 3 weeks.
Right.
We also know from this problem that she spent $50 on gifts for her family. What she bought from, who knows? And we also want to know how much money does Deja have left?
Yes, and we need to make sure we understand the question that we are to answer. How much money does Deja have left?
So let's see if I can write an equation for this. So first and foremost, what I want to find out is how much money did Deja make over those 3 weeks? So I know that she made $45 a week. And she worked for 3 weeks. Miss Holland, how can I write that? $45 a week for 3 weeks.
45 plus 45 plus 45? Or what's a shorter way of doing that?
Well, that's kind of lengthy. I think that I can write 45 times 3. That works.
Good. Because 45 times 3 would represent how much money Deja spent. But how much money Deja actually made per week.
Wow, that's very interesting. But we're not done there writing our equation. I still need to know that she spent some money. How much did she spend, Miss Holland?
She spent $50. Now, to spend means to give away.
I hate giving away money. Too bad Deja likes to.
So, let's look at that. Can I just go ahead and put the parentheses around this maybe, Mr. Valentine?
Well, actually, you could.
Because that would tell me that this is separate because this is how much she made. And once I find out how much she made, I want to spend some of that money. Would this be a good equation, maybe?
Well, let's look at it. It has the parts on how much she made, the part on how much she spent. I think this equation can answer our question.
Let's look at it. 45 times 3. Well, let's always work out our problem. Okay? 3 times 5.
Oh, you wanted me to actually say it?
Yes.
It's 135.
I know that. So we have 135 right here. Wow, she made quite a bit of money, didn't she?
Ballin'.
So she has 135 minus $50. Okay? And 135 minus $50, Mr. Valentine, is going to get you good job.
Look at me, I'm a genius.
That you are. $85. So for this part of the problem, we were able to read the problem, make sure we have a good understanding, and be able to write an equation to solve the problem. All right, let's take a look at this. Tamara baked cookies for a bake sale. She put 6 cookies on each plate. She made 4 plates of oatmeal cookies and 3 plates of peanut butter cookies.
Yuck.
How many cookies did she make in all?
Wow, that's a lot right there, Miss Holland.
It sure is. It's a wordy problem, isn't it? Let's go and look through that problem. Tamara baked cookies for a bake sale. Really? That's information I don't care to know. She put 6 cookies on each plate. She made 4 plates of oatmeal cookies and 3 plates of peanut butter cookies. How many cookies did she make in all? That's the question I need to answer. Now, this says, write this equation in such a way that it tells someone in such a way that it tells someone to add first. Wow, who typed this up?
Must have been Miss Holly.
Okay, anyways, disregard this. We're going to write an equation that it tells someone to add first. So, let's see. We have cookies and we have the amount of plates.
Right.
Now, we know she put 6 cookies on each plate. And then she has 4 plates of oatmeal and 3 plates of peanut butter. So the number of cookies is going to increase.
Of
So I know
course.
I'm going to be multiplying the cookies times the plates.
Why?
So let me see if I have 4 plates of oatmeal cookies. And then I have 3 plates of peanut butter cookies. I can add this right here.
Yes.
And once I find out how many plates I have,
Yes.
I can multiply it times 6.
Oh, I remember that from our previous video.
You sure do. That's that distributed property you was talking about.
Excellent.
Do you see that?
Yes, I do.
So then how many cookies did she have then on Mr. Valentine?
Huh?
I think it would be 42.
42.
All right? And I love cookies, so depending on if she's around me, she might not have that many left.
Hopefully she's selling them at a good price.
Okay, so again, you must be able to write an equation based on the word problem. Wow, look at this one.
Oh, this one looks kind of challenging. It says insert parentheses in the following expression 6 plus 10 times 2 so
But
that
look.
it equals 32.
Right, it has to equal 32. See, that's why we have parentheses, because it helps us out. With parentheses, we know to solve that first, because otherwise we can come up with so many different answers. But what we want to do is we want to make this equation to equal 32 using parentheses.
So let's see if I can figure this out. What would be a wise thing to do here? Well, I'm going to strategize a little bit. I know that 10 times 2, if I was to put that in parentheses, that would equal 20. And then I can add the 6.
That would equal 26.
That does not give me what I need. So, let's try something else out. How about this? What if I put the 6 plus 10 in parentheses, which would give me 16, and then I multiply that by 2.
You should get 32.
Hot dog. That worked out really well.
Awesome. Now let's look at the next part. We want to insert the parentheses in the following expression. We want to make sure that the expression equals 12 plus 1 times 2.
Well, first I have to simplify this expression here. So 12 plus 1 equals 13. And then I can multiply that by 2, which equals 26.
Right. So basically, we're trying to make that expression equal this expression.
So to make them equivalent, that's a good word there, equivalent, I have to change something up here. So now I can go ahead and try this one out. The 10 times 2.
It's going to give you 20. 6 plus 20 would give me 26.
Excellent.
You have 2 equivalent expressions.
I like that word equivalent. Are we going to use that later?
We certainly will. We'll be using that all throughout the year. Well, I think that sums up this part of the lesson. Wow, those were so fun. That went pretty fast. Wait a minute. One more. You thought we were done, didn't you?
Oh, we were done.
How could you fit the parentheses and brackets into this equation to make it true? Well, let's see. We have 14 minus 3 plus 2 divided by 3 equals 3. That's a lot going on.
Hot dog, I don't know what to do here, Miss Holland.
Okay, well, let's figure this one out together. All right, let's see. We would have, can we take 14 minus 3? That would give us 11. Plus 2 would give us 13. That doesn't make any sense.
That doesn't make any sense.
What if I take 3 plus 2, which equals 5, and then 14 minus 5 would give me what?
9.
9. So let's see. 14 minus 5 will give me 9. So I have 9 divided by 3, which is going to give me
3.
3.
But Miss Holland, I'm confused now. Shouldn't we have put that 14 minus 5 in parentheses also?
Well, you're exactly right. Because that lets us know to go ahead and solve what's in parentheses first. See, Mr. Valentine, where would we be without you?
I don't know, somewhere lost
Let's
in space.
look at that. 14 minus 5 divided by 3 equals 3. Because see, if we didn't, we would have to follow the division process first, correct?
Yes, ma'am.
But according to PEMDAS, please excuse my dear Aunt Sally, we've got to solve what's in parentheses first. And that's exactly what we want for this equation so that we can make it true. Therefore, 14 minus 5 is 9. Now we have 9 divided by 3 equals 3. Is that a little better?
That's a lot better. That just makes my day.
I'm glad. There you go, boys and girls. That sums it up for Unit 2, Part 2.
Yeah.